Hi, I'm doing this video to help you describe a piecewise function. And really, we're going to be writing the equations of lines. Complete the description of the piecewise function graph below. So there's three parts to this. There's this first blue line, the second flat line, and the third blue line as well. So it says from between -6 and -3, it obeys this. It looks like from -6 to -3, it's following this line right here. And so we need to figure out what is the equation of that line. So to find the equation of a line, we just choose 2 points that are on that line, or you need 1 point and the slope of the line. So let's look, and I try to find a point that's right on the cross hatches, meaning like it goes right where the two horizontal line and the horizontal and vertical line meet. So when our blue line actually passes right, or appears to pass right on top of where the horizontal line and vertical line meet, then I like to use that point as a point I call on the line. Why? Because it's easy for me to read that point, and it's not a fraction or decimal number. Okay, so this looks like, we have to be very careful, x is -5 and y is -2, and that is a point that's on that line. Then what we could do is we could figure out the slope by picking any other point on the line. And like this one is also touching all the crosshairs. So the slope is 1, 2 over. So that would mean a run of 2, which the run goes on the bottom because the slope is rise over run. And I moved in the positive, when I go from this point to this point, I moved in the positive x direction, so it's +2. And then I also moved 1, 2, 3, 4, 5 spaces up. So I have a slope of 5/2. Now, sometimes you could choose 2 other points on the line and then also calculate the slope, and it should reduce to the same number, 5/2. So that's a way to kind of double checking, make sure that's the right slope. But let's just double 1, 2, and then 1, 2, 3, 4, 5. Okay, that does appear to be our slope. So I have a point and I have a slope. Now to write an equation of a line, you can use the, there's 2 different methods that I know. And one is using a formula called the point slope formula. And it goes, well, everyone, usually they start with the y here on the side. Okay, y minus y1, and y sub 1 here is this value that we're going to be plugging in the point. And this first y that has no little subscript, that is our dummy variable that we're going to keep in the equation. So y minus y1 is equal to m times x minus x1. And just in case if you're wondering where this equation came from, look at the equation of the slope. This difference in y over the difference in x. And if you would solve this equation kind of for y a little bit, you'd have to multiply by x minus x1 on both the top and bottom, and both sides of the equation. I'm sorry, you can multiply that times both sides of the equation, and then these would cancel, and you would get this equation of f. The y minus y1 equals x minus x1 times m. So that's where that's coming from. And that kind of helps you memorize that equation, because then you really only have to remember one equation, the slope equation. Okay, so I substitute, and this is my x1. So these with the subscript are the ones that we're going to be substituting numbers in for. And the ones without subscript, like I said, they're dummy variables, are just going to stand there. And then the m is our slope. So we plug in 5/2 for that m. Okay, so we get y minus. Now we have to be very careful. A common error here is people forget that we need to keep the negative sign because it's part of the formula. And we also need to keep the negative sign if there is a negative sign in front of the number. Like currently our y1 is a -2. So we need to put that in parentheses and keep it negative, okay? So be very careful here. There's a negative sign coming from the fact that this point itself is negative. That's this negative sign. And there's also a negative sign coming from the fact that this formula is a subtraction right here. Okay, and we have to keep both of those, and you have to be very careful, because the mistake is, I think visually we look down and we already see a negative, and so we don't think we have to add another one. So that's the mistake here. That is common. Okay, and then I plug in the 5/2, and then I get x minus, and then the same thing happens here. I plug in, and I always like to substitute, whenever I substitute in, I usually like to use parentheses. But as you see, a negative, when I'm subtracting a negative number, it just becomes positive. So it's y plus 2 is equal to 5/2 x plus 5. And then I can distribute that out. That would be a next step. However, I would say at this point, I have this ugly fraction, and I'm not sure if this is going to help me, but a lot of time when I have ugly fractions, I like to do something to try to get rid of the fraction to make my calculations a little easier. And so what we can do right now at this step is you can, if you have just one single fraction, to get rid of it, you multiply that by that, whatever denominator is in that fraction on both sides of the equation. So I'm going to multiply by 2. And I have to make sure to multiply it on both sides. I know we're just really focused on only one side of the equation, because that's where we really need to get rid of it. But if we're going to keep this, have this be an equivalent equation to the equation above, then we need to make sure to multiply by 2 by both sides of the equation. So then these 2's will cross cancel. And now this will become 5 times x minus 5. And that calculation is a little easier for me to do than 5/2 times 5, right? And then I'll get 2y plus 4. And this equation is a little easier for me to do. Okay, 5 times x, and then I distribute and get rid of the parentheses. 5 times x is 5x. And 5 times 5 is 25. Okay, then I subtract 4 on both sides. I get 2y is equal to 5x plus 21. 2y equal to plus 4. Okay, then subtract 4 from both sides, and then I get 2y is equal to 25. Then here I divide everything by 2. And I just have to make sure that when I divide both sides by 2 here, I divide both of the terms on the right-hand side by 2. Sometimes people think they like to draw a heart, just to remind them that you have to do the 5/2 x, and you could write it 5x divided by 2, or you could write it 5/2 x. I kind of prefer to write, we're going to get the same answer after you get done calculating, multiplying things out. So 5/2 x plus 21 over 2 equals y. And there we go. That's my equation for this first part. So that's a lot of work that we had to do, and it's just for one equation, but it's not hard work. It's just work that we've seen before. So I would say the equation that we probably want in here, and notice how they don't have, sometimes they are very convenient for you and they say y equals something over here. They don't do that for us at all. So I'm assuming that we're gonna have to plug that in. Okay, y equals this 5 halves x plus 21 over 2. All right, and then now between -3 and 2 on the x-axis, between -3 and 2, what's going on? Now we have to describe it and put the equation in here. And it looks like it appears just to be a flat line. And this kind of, sometimes people get really confused with this. But you have to remember flat lines are either x equals or y equals. So it's if let m be a number. So the equation looks like x equals m or y equals some number, z or y equals, let's say n. Okay, horizontal and vertical lines, that's how I remember it. They both look like one of these two. And then I have to think about, is it x equals or is it y equals? And then I think about it and then I'm like, where is this line going through? It's going through, and as I look at this y-axis, it's going through y equals 2. So to me, no matter what x is, I recognize that y, the y coordinate, all the y coordinates of the points on this line are y equals 2. So the equation is y equals 2. And I mean, if I guessed and I said, well, I think it's x equals 2, then you would go to where, on the x-axis where it's 2, and then it would be, you ask yourself, does every point on this line have the x coordinate equal to -2, and then that wouldn't be true. That would not be the correct statement. So I would know that I got it wrong. That's how I remember it, at least. All right. Now we have to do this line. And again, I need to choose at least one point and the slope. So let's use this point, and I'll see this point as well. So now we do the same process again with this other line. The only difference is we're going to have a different slope to plug in, and we're going to have a different number, but the whole process is the same. All right. So our point, it looks like right here, is 2 and 1. And that's a common mistake, and even mistakes I've made in the past, is you switch up. You accidentally, even though this point is 2 on the x-axis, 1 on the y-axis, people will switch the x and y coordinate on accident. And I've done that before myself. And then they mess their whole problem up like that. So, okay, now we have to be careful when we're looking at the slope of this line. Notice that I do notice that when I go from left to right, like I read a page, if I imagine being a little skier on this line, if I move from left to right, like I'm reading a page, I'd be going downhill. So this is telling me it's a negative slope here. And the same thing, when I think about this one, just to double check to make sure I did my calculations correctly, when I go from left to right, whereas if I travel from left to right, like I read a page, if I travel across that line, then I would be going uphill. So I knew this was a positive slope. And I knew this appears to be a negative slope, and a large negative slope, close to the 5 halves. Like they look like they're the same but opposite, right? All right, so 2, 1, and then now let's figure out what the actual slope is. So like I said, slope is equal to rise of a run. That means how much the rise is how much up and down, and the run is how much left and right. It is between any 2 points that you pick on the line. Like I said, pick 2 points that are crossing the crosshairs of, they're actually right on, you know, where a vertical and horizontal line meet. And I've chosen to, and so like I just focus on going from this point on the left to the point on the right. It doesn't matter, I could have done the other direction as well, but I'm gonna go, so I go 1, 2, 3, 4 spaces I have to move down to get to this point. So that's a rise of -4. And then I have to go 1, 2, which is 2 spaces to the right, which is the positive. I had to go down and over to the right to get to the second point. So that would give me a slope of -2. Okay, so our slope, M, is -2. I guess the other one was 5/2 or 2.5, so they're similar. Okay. Now, and one thing I did want to mention too with slope is you were like, well, you've calculated the slope by starting at this point and going to this point. Would I have gotten a different slope if I started with this point and traveled to that point? Okay, so let's go up. So let's do that. Let's do 1, 2, 3, 4 spaces up. So my rise would have been 4, but then I'm going 2 spaces backwards. So my 1, 2, it would be a -2 in the run. And so it would be ending up the same answer, -2. So no matter, I always think about what do I have to do to travel from one point to the next. And that's how it helps me do my slope. But so just to help you with that. Okay. All right, so then next I just plug in the 1 for the y, and I plug in the -2 for the m. Should probably put that in parentheses as well, and then x minus the +2 for the x. Sometimes I like to say these things out loud because I tend to like lose mental focus, you know, just when I'm just not paying attention that well. And, and sometimes talking to myself or saying things out loud kind of helps me focus. So -2 times x is -2x. And then -2 times -2 is +4. And then now all I have to do is add 1 to both sides. And then I get y equals a -2x plus 5. And that's my third equation. And there we go. Let me just double check the answer. Okay, one correction that is just a small thing here, and yet, you know, after getting all of this correct with these type of programs, we have to be really accurate in the way we present our answer. We have to listen to them closely. I didn't recognize, but because I was looking, I guess, right in front. I was like, look, they don't have a y equals, but technically they do have it because look, it's right here. F of x equals. So I shouldn't be putting these y equals signs in, and that may be the error that some of you are making. But after I just put these equations in, then it was happy with that answer. All right, have a great day. Bye.